Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the design guidelines for the flexible pavements as per the Indian Road Congress, section 37 as per the 2012 recommendations. Now, the design guidelines for the flexible pavements were first introduced in the year 1970, which were based upon the CBR value, that is the California bearing ratio of the subgrade, and the traffic in terms of its number of the commercial vehicles which were weighing more than 3 tons. Now these guidelines, they were again revised in the year 1984, then back again in 2001, and currently as per the syllabus is concerned, here we'll have to consider the revised guidelines as per the 2012 recommendations of the Indian Road Congress. Now the guidelines, they shall apply to the design of the new flexible pavements for the construction or the design of the expressway, the national highways, the state highways, the major district roads, and the other categories of the roads such as the ordinary district roads, then the village roads. Now the recommendations of the design guideline for the flexible pavement as per the IRC 37/2012 are as follows. First, to consider the design period of the pavement for more than 15 years. That is, whatever is the pavement which has to be considered, which has to be designed, it will be designed with the design period of more than 15 years. Next was to determine the effective CBR value of the subgrade in the pavement design. That means the CBR value of the subgrade, it was necessary to be known for the pavement design. Next was the rut resistance surface layer to be introduced. Now rut resistance or rutting, it is a permanent deformation of the pavement, and it is basically being caused by the repetitive application of the traffic loading. So a layer was to be introduced which shall resist this deformation of the pavement under the influence of the repetitive loading of the vehicular movement onto the pavement. Next was the use of the fatigue resistance bottom bituminous layer. So introduction of the bitumen in the below lying layers. Now that might be the base course, the sub-base course. These layers, they were introduced with the bitumen. So this introduction of the bitumen, while these below lying layers, apart from the surface layer was concerned, it actually enhanced these layers to fatigue resistivity. That means the base course, the sub-base course, when bitumen was being introduced, they became more intact, and the better binding in between the aggregates and the rolling action, which provide the strength to these bottom layers, it actually introduced the fatigue resistivity into the pavement. Next, in order to prevent the top-down cracking, the surface layer was being selected. That means if there is the cracking into the surface layer, then these below lying layers, they should be selected in such a way that means the use of the bitumen, the use of the aggregate, then again the depth of the pavement, it was selected in such a way that this formation of crack from the surface to the bottom lying layers, it will be prevented. Next, in the base course, there shall be the use of the bitumen emulsion or the foamed bitumen treatment reclaimed asphalt pavements. Now, as discussed earlier, there should be an introduction of the use of the bitumen into the below lying layers just in order to enhance the strength capabilities and the fatigue resistivity by these layers. Next, the stabilized sub-base and base with locally available soil and aggregates shall be considered. This use of the locally available soil and the aggregates, it was recommended, and there was a need regarding the design of the drainage layer. Now, as we know that the pavement, it actually deteriorates when water is introduced into the pavement. Now, that can be from the surface or by the side penetration of the water into the pavement layers. Now, if there is a provision of a drainage layer in the pavement, it shall drain off the water present in the layer, thus increasing the durable span of the pavement. Next was the in regards with the equivalent single axle load. It shall be determined by considering the single axle with the single wheel, the single axle with the dual wheels, and the tandem axle and the tridem axle. That means the total loading. It was decided depending upon the axle loadings of the vehicles. Next was the perpetual pavement with the deep strength bituminous layer. It shall be designed. So these are the recommendations as per the Indian Road Congress. Next, we shall see the stresses in the flexible pavement. Now we know that the deformation in the flexible pavement, it basically causes under the maximum wheel loadings, the dual or the multiple wheel loads or the equivalent single wheel loads, and the repetitive loading caused by the traffic and the tire pressure. So there are certain stresses which will be induced into the pavement just because of this application of loadings. So the stresses in the flexible pavements are as follows. First is the vertical stress, and second type of the stress which will be induced in the flexible pavement will be the contact pressure. Now in the first case, vertical stress. Now this vertical stress basically was studied as per the Bozenick's theory, and Bozenick in the year 1885 he developed a theory to calculate the stresses and deformation due to the point load applied at the surface of the semi-infinite soil mass. That means whatever is the application of the loading, it was considered at a particular point, and the soil mass and the assumptions made by Bozenick were as follows. The soil mass, it is elastic, continuous, having a constant value of the modulus of elasticity E, and it obeys the Hooke's law. The soil present in the pavement layers below in the subgrade, it was assumed to be homogeneous, that is, it has an identical elastic properties in all the points in the identical directions. That means whatever is the soil present in the pavement layers, it is elastic, it has elastic properties in all the points and in all the directions equally. The soil, it will be isotropic, that is it will have the identical elastic properties in all the directions at a given point. Then the self-weight of the soil, it was ignored. If we consider the pavement layers, then the self-weight of the soil, it was ignored, and only the loading from the vehicle, it was considered at the given point. The top surface of the pavement is free of the shear stress, and it is subjected to only the point load at a specific location. Now, as there is no consideration of the self-weight of the soil, hence this top surface of the pavement, it will be free of the shear stress. That means no shear stress it will be considered, and again only the point load at the point of application it will be considered, and the stress, it will be distributed symmetrically with respect to the Z axis, that is the vertical axis. Now the equation for the vertical stress, to determine the uniformly distributed circular load based upon the Bosnick's theory is given as sigma z equals to p in the bracket 1 minus z cube upon a square plus z square bracket raised to the power 3 by 2, where sigma z, it is a vertical stress at the depth z. As you can see from the figure, the total depth z, it is considered where the vertical stress it has to be found out. Then P is the surface stress, Z is the depth at which sigma z it is to be determined, and A, it is the radius of the loaded area. Here it was also assumed that the loading which will be caused at the point of contact in between the tire and the pavement, that means the wheel and the pavement, whenever there is an application of the loading at that point of contact, the point of contact it will be elliptical, but for the ease in the design, that particular point of contact it was assumed to be circular. Hence we considered it to be as a as the radius of the loaded area. Next, again, these are the equations in order to find out the stresses. First is sigma z equals to p upon 2 pi in the bracket 3z cube upon r raised to the power 5. Then sigma r equals to p upon 2 pi in the bracket 3r square multiplied by z upon r raised to the power 5 minus 1 minus 2u upon r square plus z into r. And sigma t equals to p upon 2 pi multiplied by in the bracket 1 minus 2 mu bracket complete multiplied by z upon r cube minus 1 upon r square plus z into r. So this is sigma z, sigma r and sigma t are the stresses due to a point load in all the three axes. That means the x-axis, the y-axis and the z-axis. The stresses caused due to the application of the wheel load, they can be calculated using the following equations. Next, if you see the shrinkage stress and strain and temperature stresses and strain cracking, they are being developed just because of the application of the wheel loadings onto the layers. Now in the top portion, if you observe, there is the maximum application of there is a maximum introduction of the vertical stresses, and they go on diminishing as the depth of the pavement it goes on increasing. So this was the basic concept which was being followed by Bosnick, that the effect of the loading in regards with the consideration of the vertical stress, it will be prominent at a shallower depth, that means at the top layers, and at a depth infinity or at a certain depth this vertical stress it diminishes. That means that vertical stress it becomes zero. Next is the contact pressure. Now as we have seen from the above figure that the influence of the tire pressure it is prominent only in the upper layers, and the total load it exhibits a considerable influence on the vertical stress magnitude because of the effect of the tire pressure it diminishes at a greater depth. Hence, the high quality of the material is required in the upper layers of the pavement. So just in order to counteract these vertical stresses which are being induced into the pavement, it is necessary that the upper layers of the pavement, they shall be designed in such a way that they will be in a state to resist this vertical stress and provide utmost stability and strength to the pavement. Now with this constant tire pressure, the total load, it governs the stress on the top of the surface subgrade within the allowable limits, and the stress under the steel tired wheels are very high, and it requires the use of very strong and hard aggregates for the wearing surface of the pavement. Now this steel tires wheels are in concentration with the tires of the bullock cart, while the magnitude of the load is very less as compared to the commercial vehicles. Hence, again, the surface area or the point of contact of this steel tired wheels, it is also very less. So it is recommended that the use of the strong and hard aggregates for the wearing course of the pavements, they shall be used. Next, the wheel load, it will be generally assumed to be distributed over a circular area. Now as we have discussed earlier, although whenever a wheel it comes in contact with the pavement, the contact area formed, it will be elliptical in shape, but just because for the ease in the design, the area over which the load it is being distributed, it is considered to be circular, and the contact pressure is more than the tire pressure when the tire pressure is less than 0.7 Newton per mm square, that is 7 kg per centimeter, and the contact pressure can be determined using the following relation as contact pressure equals to load on the wheel upon the contact area. So these are the two stresses which will be induced into the pavement, which has to be considered. So with this we shall stop. Thank you.